Hello everyone, and welcome to a new video in the TryHackMe playlist. This is my first walkthrough video on TryHackMe, and in this video, we'll be exploiting and gaining privilege escalation on a vulnerable VM called Ice. You might wonder why I chose this VM. During my time with VulnHub, I never encountered any Windows vulnerable VMs. So, I decided to explore TryHackMe. Although there are several Windows VMs available, I decided to start with a free one, and Ice was my choice. As I mentioned in my introductory video, TryHackMe is known for its structured learning paths. In this video, our goal is to follow the given tasks, deploy, and hack into a Windows machine by exploiting a poorly secured media server. Task 1. Connect. Connecting to the TryHackMe network is the primary step, and it's crucial to remember that you must connect every time you start your attacking machine. To connect to the TryHackMe network, we use a bridge, and the most commonly used one is OpenVPN. If you've watched the Hack the Box series, you'll be familiar with how we use OpenVPN for this purpose. Here's how to do it. First, download the configuration file. So, visit the TryHackMe access page and download the OpenVPN configuration file. Now, open a terminal. Use the OpenVPN client tool to connect. Ensure you use sudo for the command. When you run this command, you'll see a lot of text. At the end, it should say initialization sequence completed. You can verify your connection by looking at your access page on TryHackMe. Refresh the page, and you should see a green tick next to Connected. It will also show your internal IP address. Now that you're connected, you are ready to use the machines on the TryHackMe network. In Task 1, under the Connect section, we downloaded the configuration file and then connected using OpenVPN. Next, I demonstrated where to find the internal IP address. When we deploy the VM in our task, you'll see its internal IP address. Note that, the virtual machine used in this room, Ice, can also be downloaded for offline usage. Click on the provided link to access the download page. Additionally, the sequel to this room, Blaster, can be found there as well. Task 2. Recon. In the past, I used the term enumeration, which is synonymous with Recon. So don't get confused by the terminology. Our first priority is to scan and enumerate our target. But before we do that, we need to identify our target. First, we have to deploy the machine. This may take up to 3 minutes to start. Once the machine is deployed, the target IP address will be provided. For this task, the target IP is 10.10.162.253. Before proceeding, ensure that the target is reachable by performing a ping test. This helps confirm that the target is connected to our network and is receiving data. So, let's now perform a network scan to detect which ports are open. This is a crucial part of the Recon process as it helps us understand the attack surface and plan targeted attacks. We will use the famous Nmap tool for this purpose, where the -sc option is used to perform a script scan using the default set of scripts. It's useful for gathering additional information about the target. The -sv option enables version detection, which identifies the versions of services running on open ports. The -pn option is used when we want to perform a scan without pinging the target first. It treats all hosts as online, which is useful if ICMP requests are blocked. The network scan reveals several important details about the host at IP address 10.10.162.253, which appears to be a Windows 7 machine named DarkPC within a workgroup called Workgroup. The scan identified 10 open ports, each associated with specific services. 135 TCP, MSRPC. This port is used by Microsoft Windows RPC, Remote Procedure Call, a core functionality for communication between applications and services. 139 TCP, NetBIOS SSN. This port is used by Microsoft's NetBIOS name service, enabling network browsing and resource sharing. For 45 TCP, Microsoft D is commonly used for SMB, server message block, file sharing. This port provides access to Windows file systems. The scan also revealed that the operating system version is Windows 7 Professional 7601 Service Pack 1, and the machine is part of the workgroup. 3389 TCP, SSL MSWBT server? Typically used for Remote Desktop Protocol, RDP, with SSL, this port was found to have a self-signed certificate named DarkPC, valid from July 22, 2024, to January 21, 2025. 5357 TCP, HTTP. This port hosts a basic web server running Microsoft HTTP API HTTPD 2.0. The server responded with service unavailable. 8000 TCP, HTTP. Another web server is potentially running on this port, possibly an Icecast streaming media server. However, specific title information was unavailable. 49152 TCP, 49153 TCP, 49154 TCP, 49158 TCP, 49159 TCP, 49160 TCP, MSRPC. These ports are associated with additional Microsoft Windows RPC services. They are currently identified as unknown, and further investigation might be needed to determine their exact purpose. Let's back to the given question. Here, it is asking, what is the port number of one of the more interesting ports that is open in Microsoft Remote Desktop, MSRDP? As I already told you, this is 3389. The next question is, what service did the Nmap identify as running on port 8000? First word of this service. This port 8000 runs the Icecast streaming media server. So, the first word of this service is Icecast. The next question is, what does Nmap identify as the hostname of the machine? The hostname identified by the Nmap is DarkPC. Now, let's move on to Task 3. Task 3, Gain Access. Gaining access involves exploiting a vulnerability to establish a foothold on the target system. In our previous task, we identified several interesting services running on our target machine, including Icecast. Icecast is an open-source software that allows streaming audio content over the internet, much like a digital radio station. It can be used for creating online radio stations or hosting personal audio libraries. However, the version of Icecast running on our target has significant vulnerabilities with a high-risk level, scoring around 7.5 or 7.4 depending on the source. Here, it is a question, what is the impact score for this vulnerability? A hint was provided to use cvedetails.com to find the impact score. However, I couldn't find the information directly on the site. Instead, I used a useful trick. A Google search led me to an ExploitDB link where the CVE details are available. The vulnerability in question is associated with Icecast 2.0.1 Win32 and is identified as CVE 2004-1561. Based on the details found, the impact score for this vulnerability is 6.4. The next question is, what is the CVE number for this vulnerability? The CVE number is already told, that is CVE 2004-1561. Now that we've identified the vulnerability, let's find and use the corresponding exploit with Metasploit. Let's go ahead and launch the Metasploit framework. Once the Metasploit console starts, search for the exploit related to Icecast using Search Icecast. It shows us one module related to Icecast. Let's go ahead and select this module for use. Type the command use 0 to select our search result. Following selecting our module, we now have to check what options we have to set. Run the command options. By looking at the options, we'll need to set the R host's target IP address and the L host attacker's IP address. The IP address for L host can be found on the TUN0 adapter. With all options set, we are now ready to execute the exploit. Upon successful attempt, we have successfully got an interpreter session. Before we move on to the fourth task, let's answer the given questions. What is the full path for the exploitation module? The path for the exploitation module is exploit/windows http Icecast header. The only required setting currently left blank is our hosts. Although lhost is required, if you are using a paid membership or an online attacking machine, lhost might already be set. Task 4, Escalate. Previously, we've successfully gained access to the victim machine. Now, it's time to enumerate the system and identify potential privilege escalation paths to gain administrative powers. Let's follow the steps below to gather the necessary information. To distract our path, we will follow the questions below. What's the name of the shell we have now? We are currently using the Meterpreter shell. What user was running that Icecast process? To determine which user is running the Icecast process, we need to check the running processes. Use the ps command in Meterpreter. From the output, you'll see that the Icecast process, icecast2.exe, is running under the user dark. What build of Windows is the system? To get the Windows build information, use the sysinfo command in Meterpreter. The build number of the Windows system is 7601. Now that we know some of the finer details of the system we are working with, let's start escalating our privileges. First, what is the architecture of the process we're running? From the system information, we already found that the architecture is x64. As from the system information, we already found that the architecture is x64. Now that we know the architecture of the process, let's perform additional reconnaissance. Although this may not be as effective on x64 machines, we should run this command to find potential exploits. This command may appear to hang for a few minutes as it tests various exploits. Once it completes, it will provide a list of potential local exploits for privilege escalation. From the results, we have to select an appropriate exploit that could provide full access. For this walkthrough, we will choose the first exploit. Here, it is asking, what is the full path for the first returned exploit? The path for the first exploit is exploit/windows/local/bypass UAC event viewer. Once you've identified the exploit to use, background the current session to proceed with the next steps. You can do this by typing background or by pressing Ctrl+Z. Before proceeding with the exploit, take note of the session number you have. You can list all active sessions by using the command sessions when outside the Meterpreter shell. In my case, the session number is 1. Now, go ahead and select the previously identified local exploit with the command use, and then specify the full path for the exploit. It's time to check the available options to configure. Local exploits require a session to be specified, so set this by running set session and then specify the session number, that is 1. After setting the session number, additional options need to be configured from the options menu. We'll have to set one more as our listener IP isn't correct. So, set the lhost option now. Here, it is asking, what is the name of this option? The answer is our host. Once the necessary options are configured, we now can run the privilege escalation exploit by typing run. Please note that this might take a few attempts, and you may need to restart the machine and re-exploit the service if the initial attempt fails. After successfully escalating privileges, a new Meterpreter session should open. After completing these steps and obtaining another Meterpreter session, let's check for user privileges. So, we can now verify the expanded permissions using the command getprivs. Here it is asking, what permission listed allows us to take ownership of files? The Say Take Ownership privilege permission listed allows us to take ownership of files. Let's move on to the next task. Task 5, Looting. In this task, we will learn how to gather additional credentials and crack the saved hashes on the machine. Before proceeding, we need to migrate to a process that has the necessary permissions to interact with the SaaS service, which handles authentication in Windows. Prior to further action, we need to move to a process that actually has the permissions that we need to interact with the SaaS service, the service responsible for authentication within Windows. To identify a suitable process, we first list all running processes by using the command ps. This will display a list of processes along with their process IDs, PIDs, names, and the users running them. Now, we have to identify a suitable process. Look for processes running under the NT Authority System account. Even though our current process may not have the required permissions, we can migrate to a process running as system to gain full access. By migrating to a system-level process, we gain the necessary privileges to interact with the SaaS service and extract credentials. Once we've identified a suitable process, we can proceed with the migration and begin gathering credentials. In order to interact with SaaS, we need to be within a process that matches the architecture of the SaaS service, x64 in this case, and has the same permissions. The printer spool service is ideal for this purpose, as it meets the necessary criteria and will automatically restart if it crashes. Let's answer the question, what's the name of the printer service? The answer is spools.exe. When we say living in a process, it refers to the technique of injecting malicious code into a running program by loading a shared library, DLL, into it. This can allow us to spawn a new thread that hosts our shell. To migrate to the printer spool service, use the command migrate-n and specify the process name. This will automatically migrate the interpreter session to a more stable process, such as explorer.exe, to conceal it. Now, proceed to the next question in this task. Let's check the current user. After migrating, verify the user context by running the command getuid. What user is listed? The answer should be NT Authority System. Now that we've achieved full administrator permissions, we can focus on extracting valuable information and credentials from the system. Mimikalz is a well-known tool for dumping passwords and is incredibly useful for gathering credentials. In our interpreter session, we can use the updated version of Mimikalz, known as Kiwi, by loading it with the command load Kiwi. Use the command load Kiwi to load Kiwi into the interpreter session. This will expand the help menu with new commands available for use. Check the newly added commands by typing help to see what options are available. Here it is. Here is asking, which command allows up to retrieve all credentials? The answer is the creds_all command, which retrieves all credentials from the system. Run the creds_all command to dump all available credentials. Mimikalz can extract these passwords from memory, even if the user dark is not currently logged in, thanks to a scheduled task that runs Icecast under the dark user's account. Additionally, the absence of Windows Defender on the system makes this process easier. Here, it is asking, what is dark's password? The password is password01. Now that we've retrieved the necessary credentials, let's move on to the next task. Task 6, Post-Exploitation. Let's explore the post-exploitation actions we can take on a Windows system. These actions can provide valuable information and access, but they should be carried out with caution and only when authorized. Before diving into specific actions, let's revisit the help menu in the interpreter shell. We'll use it to answer the following questions. What command allows us to dump all of the password hashes stored on the system? The answer is #dump. The #dump command allows us to dump all the password hashes stored on the system. Note that while we can obtain these hashes, we won't attempt to crack the administrative password, as it is intentionally strong to prevent password spraying attempts. While more useful when interacting with a machine being used, what command allows us to watch the remote user's desktop in real time? The screen share command allows us to view the remote user's desktop in real time. This is particularly useful when the machine is actively being used. How about if we wanted to record from a microphone attached to the system? The record mic command can be used to record audio from the system's microphone. To complicate forensics efforts, we can modify timestamps of files on the system. What command allows us to do this? The timestamp command can modify the timestamps of files. Now, proceed to the next question in this task. Important note, this action should only be performed if explicitly allowed, as it can complicate the forensic analysis of a pen test. Mimikalz allows us to create what's called a golden ticket, allowing us to authenticate anywhere with ease. What command allows us to do this? The golden ticket command within Mimikalz allows the creation of a golden ticket. This attack leverages the Kerberos ticket granting ticket to maintain persistence and authenticate as any user on the domain. Golden ticket attacks exploit the Kerberos authentication system used in Windows domains. They allow an attacker to create a valid ticket that can be used to access any service in the domain, maintaining long-term access even after passwords are changed. Now, proceed to the next question in this task. One last thing to note. With the password for the user dark, we can authenticate to the machine via remote desktop, MSRDP. While this provides a unique perspective, be mindful that connecting via RDP may disrupt the user currently signed in. If RDP hasn't been enabled, we can do so using the Metasploit module, run post Windows manage enable RDP. This command will enable RDP access, allowing us to view the machine as the user would. Let's move on to the final task. Task 7, Extra Credit. This task was already covered in Task 3, where we explored manual exploitation using exploit code found on ExploitDB. As you progress in your pen testing journey, you'll inevitably encounter scenarios where you need to exploit vulnerabilities without using Metasploit. We provided a link to an ExploitDB entry that details an Icecast vulnerability allowing for remote code execution. While it's not a requirement for this task, it's highly recommended to try exploiting the vulnerability using the provided code or a similar exploit. This will help you develop and refine your manual exploitation skills. If you have any questions or concerns related to this video, please feel free to leave them in the comments section below. We're here to help.